Hi, my name is Kevin Thomas. I'm a grade 11 student at Burnaby South Secondary School, and I'm really passionate about math, computer science, software development, and similar concepts. Over the last few months, I've been trying to learn more about AI and ML, and just a few weeks ago, I demoed my first project, which was ASL fingerspell recognition using Google MediaPipe and a PointNet model. Since then, I've added a lot of new features, including the ability for my software to express ASL instead of just receive ASL, and today I want to demo some of these new changes. Just to give a quick background, I go to Burnaby South, which is also home to BCST, BC Secondary School of the Deaf. And over the last 4 years, this has given me the opportunity to learn ASL in school, which has given me a lot of insight and also inspiration to work on this project. So I'll give you a quick demo right here. I like soccer. The software can sign what I say. So I have a document that outlines my process and the complexities of this project and ASL transcription overall, but I'll just give a brief overview of the technology and the complexities of ASL itself. So on the left here, you can see what a normal conversation looks like. Person two speaks, person one receives, person one speaks, person two receives. And this is how a normal conversation works. But then the moment you have a language barrier, you have a tool in between that effectively translates between language one and language two. So as you can see here, the purple tool in between acts and serves in between both the people. And in a normal deaf to hearing conversation, we usually have a human interpreter that facilitates this conversation. But between ASL to hearing individuals, we don't have any technological tool that can act as a translation tool that can facilitate a conversation. So, for example, between English and Japanese or English and Chinese, we have Google Translate that can translate between any languages. But we don't have an actual tool for ASL translation. And so this is what the most effective translation tools work as right now. They're effectively just text to speech or speech to text. And so they have the English person speaking and receiving and listening just like they normally do. But the deaf person has to do all the extra work of converting written English to ASL gloss to ASL signs. They can process the signs before they need to use the ASL signs, convert to ASL gloss to written English, just for the tool to speak it out for the hearing human. And so the problem with all these services is that they're built with English as the primary language. They are not built to reduce the complexities of the amount of work the deaf person has to do. And all of this stems from the misconception that ASL is the same language as English, but ASL actually has its own grammar, its own vocabulary, its own syntax, etc. And the problem is that all these tools require the deaf person to do all these extra steps, which is what I've been working to overcome in my own project. The main goal is to effectively the main problem is that these services effectively look at deafness as a disability. So all they do is bypass the hearing part of the conversation. So they make it so the deaf person can read what they say because they can't hear it. But the fact is that ASL is a completely separate language. So it needs to be translated from one language to another because English is not the same as ASL. And this is what I've been working on for my project. And there's a few main complexities with this in the first place. So one, in the expressive part of the technology, which is where the deaf person speaks and the software processes the signs. The main problem is that one, they often don't work in real-time settings because it's a lot of processing power, and two, they're not consistently reliable. So when people have different skin colors, different backgrounds, different hand sizes, they usually become less reliable. And two, for the receptive part, where the software effectively listens in English and speaks out in ASL, the main problem is the size of vocabulary data sets in today's world. So actually, when I first started, I was using a convolutional image classification model to essentially take a picture of my hand and use patterns in this to decide what alphabet it is. But the problem, again, I had was that different races, different hand sizes, different backgrounds would effectively make the model basically unreliable. And so to combat this, I used Google MediaPipe. Google MediaPipe essentially takes an image of a hand and identifies points of joints on the hand. And this solves two issues. One, it makes it a lot easier to process because we're just dealing with points instead of actual images. And two, it makes it a lot more reliable because it's not dependent or vulnerable to changes in hand sizes, changes in positions of hands, background color, and skin tone. So that way, Google Media Pipe assisted in many ways. So basically, what I did was I trained a point net model using points of a hand. So I downloaded existing data sets of ASL alphabets, and then I fetched the points from each of them, and I trained an AI model using about 125,000 images of hands. But instead of using images, I used the points in each of those images. And so this makes it a lot faster and a lot easier for the model to actually classify what alphabet is shown by the points. So that helped me solve the reliability and the consistency problems with the expressive part of the ASL project. And finally, for the receptive part, which I effectively, basically what I did was one, I downloaded about 9,500 words, and this was my initial data set of all the words that my ASL avatar could sign. And so when I speak, it transcribes my speech into text using a normal text to speech to text service, and then it signs these words out exactly as they are. And to increase the size of the data set and increase the vocabulary, I basically stored embeddings of every single word. And so, for example, if I was saying the word food, and see I didn't have the word food in my database, it would look at contextually similar meaning words like meat, eat, hungry, snack, etc. And if it falls above a certain threshold, then I use the sign for that word instead of the sign for food, basically. And so this document outlines all the work I did and the processes and how they work, and I'll attach it to the description below. But that's basically how the project works. So there are definitely some limitations to my current project, and it's only been a few months that I've been working on it. So for one, it only when it's transcribing ASL signs, it actually only transcribes ASL fingerspelling, which is only about 30% of ASL communication, like expressive communication. So that can be combated by using LSTMs or recurrent neural networks in the future, but it's something I still need to learn a lot more about and look into in the future. Two, for the receptive part, where the software listens in English and signs the words, it's really good right now, and it fingerspells any words that are not in the database, which is effective. But it still signs in exact English, which means it doesn't rearrange the words to format English into ASL grammar. And the reason I have it like this right now is that so that the interpreter can actually sign it in real time. But in the future, I can use LLMs or any like natural language processing to rearrange the sentences to follow ASL grammar structure. And so this is what it looks like. This is what ASL to English grammar looks like. But yeah, this is the main project right now. In the future, I see a lot of possible things that can happen. One, I want to make this modular so I can make it publicly accessible so anyone can access this and just try it out. Two, I also want to make this a standalone. This can be used as a standalone client, so I can either can be a webcam client or a Chrome extension, and it'll essentially enable people to transcribe their speech into ASL signs effectively. So if I'm a YouTuber, I can use the software to add an interpreter below my webcam, and it'll make my videos accessible to anyone. Or two, the Chrome extension can effectively add a caption option to YouTube videos where it would just have an interpreter transcribing everything that's said in the YouTube video. So I think making this modular and open source will allow anyone to build on top of it. And hopefully this will encourage some more people to build cool accessibility technology. Number two, making it publicly accessible will hopefully also get some more people looking at ASL and trying this out. And hopefully the novelty of this project itself will encourage some people to learn ASL or get into accessibility technology. But for now, I'm just aiming to make something that people in my school can use to effectively, for BCSD students and Burnaby South students, to communicate without the need for a human interpreter. And I'm hoping the novelty of the project itself encourages people to, try it out. But yeah, that's all from me. I'll link the document down below as well as my previous demo video. And thank you so much for your time. And I'm looking forward to seeing where this can go. Thank you.